In this lesson, I will explain to you Bayes' theorem, which is necessary to understand before going to naive Bayes' theorem. So it says that probability of A given that B is given is equal to probability of B given that A is given multiplied by probability of A divided by probability of B. So first of all, I will prove this theorem, that how come this side is equal to this side, and then we will solve an example to understand more about this theorem. As we have discussed in conditional probability, that probability of A, how to read this, right? This line means given that. Probability of A given that B is given, or probability of A you have to find out while B is given. The probability of B is given, which is equal to probability of A intersection B and divided by probability of B. Right, first I will quickly show you the concept of what is the meaning of A intersection B. Suppose we have two sets. In first set we have A, B, C, and we have another set in which we have A, C, and D. If someone will ask you what is A intersection B, intersection means common, which is present in both the sets. So A is present, or A is common between these two, and C is also common. So the intersection will be A and C. So this is the story of intersection. I will say this is my equation number one. Now, instead of A while B is given, if I will write down probability of B while A is given, so this will be equal to probability of B intersection A divided by probability of A. So this is my equation number 2. Right here, come back here. This is A intersection B. If I will ask you what is B intersection A, so both have the same meanings, means which are present in both the sets. So the answer is same, A and C. Right. So here see, if A is written first, then this is the formula. If B is written first, then this is the formula. So next step is cross multiply equation 1 and 2. So see, cross multiply means we will multiply this probability of B with this, and here in the numerator we do not have anything, it means 1. So it will be probability of A while B is given multiply by probability of B, because we are taking this to the left hand side. So on the right hand side only we have A intersection B. So I would say that this is my A dash. Similarly, cross multiply equation number 2, it will be probability of B while A is given probability of A, which is equal to whatever is left here, probability of B intersection A. So this is my 2 dash. As I have mentioned here that A intersection B or B intersection A both are same. So see here, this is equal to this and this one is equal to this. Both are exactly same, A intersection B and B intersection A. It means that these two left sides are all also equal. Left hand side is equal to right hand side, and on right hand side we have this and this, exactly they are same. Even though here A intersection B, here is B intersection A, but the answer is same. It means these two are equal. So we can write down A, probability of A while B is given, probability of B is equal to probability of B while A is given multiplied by probability of A. So now if we compare this and this, so here on in this theorem we have only probability of A while B is given on the left hand side. So we will keep this on the left hand side and see when it will go, probability of B will go to the other side of the equation. It means we have to divide this probability of A, this whole divided by probability of B. Now this proves this, our theorem, both are exactly same. Right, so here we have proved the Bayes theorem. Now probability of A divided by probability of B while B is given is equal to probability of B while A is given. Again, I am writing this theorem here to explain you few more things. Here is probability of B. Now our question is, according to the Bayes theorem, we have to find out the probability of A while B is given. So in order to find out this left hand side, you need to find out three more probabilities. Probability of B while A is given, probability of A, and probability of B. Now the question is, what is probability of A? Probability of A is called prior probability. This one, probability of B, is called the marginal probability. Probability of B while A is given is called the likelihood, and this part is called the posterior. If someone will ask you what these probabilities are in Bayes theorem, so you have to say like this: posterior, likelihood, prior divided by marginal probability. Now, one more thing before going to start our question or example. So see this A, wherever you will see A in this equation, it means this is our hypothesis, and B means data or evidence. It means that you have to find out the hypothesis, the probability of A, which is hypothesis, while data is given, because it means that find out the value of A or the probability of A when while B is given. So what is B? B is our data values or the evidence, which is equal to probability of B. What is B? This is data. Here you have to find out the probability of our evidence while we consider that our hypothesis is given or our hypothesis is true. This one only our hypothesis, probability of our data. Now we will start the example. Suppose if I will say that I have to pick any card out of a deck. There are 52 cards in a deck. I pick a card and that is called the face. What is the probability that this face will be queen or jack or king? Right, I pick this card. So this is my data value. This is my evidence. This is my B. B is given. But on the basis of only B, we cannot make any conclusion. We have to find out these three probabilities as well. So see, whatever I said, I am going to write down here. Probability of A. A is queen. What is the probability? Find out the probability of the hypothesis. B is given, means face is given. Maybe face will be jack or queen or king. But you have to find out, right? Is equal to, just follow this pattern. Probability of B. In this case, we have face divided by queen. Then probability of A is queen divided by probability of B is face, because I said wherever is our B, it means evidence or data, whatever is given. So face is given and the A is our hypothesis we have to find out. Now suppose if I will pick a queen, because queen is given, what is the probability of the face? So it is 1. Now here is only queen. What is the probability that I will pick a queen? There are 4 queens in a deck and there are 52 cards. So there are 4 possibilities that I will pick a queen. Same thing here. Probability, there are 52 cards. What is the probability that I will pick the face? 4 for jack, 4 for queen, 4 for king. Now only you have to simplify. So there are 2 or 3 different ways how you can simplify. I will make very easy. Start by using 2. 2 times 4, right? 2 times, and then it will be 1 over 13. Here 1 over 13 in the numerator. Just do whatever you want. Okay, 2 6 times, 2 2 times, here 2 3 times, and again 3 over 13. When I will simplify it, it will be 13 multiplied by 13 over 3. Very great, 1, right, or 2, which is equal to 1 over 3. So the probability of the coin while face is given is equal to 1 over 3. Right, now I hope the Bayes theorem is clear to you. So please practice it. Subscribe to my channel and thanks for watching.